I'm Donna Faust, this year's president. Welcome to Lifelong Learning. Please take a moment to silence your phones, if you would. Today we have part 2 of last week's presentation on controlling climate change. As you can see, our members enjoy many benefits of club membership. The best benefit for me is that our very talented video team records every presentation, which is then posted on our website, but you need to be a member to access that website. And by the way, last year our videos were viewed 1,700 times, over 1,700 times. So it really is a great benefit for our members. Before I tell you about our exciting programs coming up, the association would like you to know that the views expressed by in our presentations are those of the presenter and may not reflect the views of the association nor our club leadership.
Good morning. Let me pull this thing out here. I can do it without breaking it. Good morning again. We are doing our second session on climate change from 2 different perspectives, astronomy and geology. We covered the astronomy portion last week and a half, and now we're going to go into the geology. And what we'll do, first of all, we'll start off with a very brief review, about 30 seconds, of what we covered the last session, and then we'll see an overview of what we're going to talk about today. So, first of all, last session, by the way, how many people, are there any people here that missed the first session? Okay, I encourage you, you can of course go and see that program on the internet. I encourage you to do it. But what we talked about, first of all weather systems are driven by a tremendous amount of energy. And the predominant source of energy on Earth is from the sun. And there is a secondary source, which is much less energy, but is still very important. And that is the source of energy in the internal heat in the center of the Earth. And energy from the sun is constantly increasing, while energy from the interior is decreasing. And both are essential for the survival of all living species on the planet. And unfortunately, the sun, which is constantly getting larger with time and hotter with time, has already killed all of our nearby planets, as believed by scientists. Mars, Mercury, and Venus were next to go. It's 3 down and 1 to go. Now, we have plenty of time. That's not going to happen tomorrow or day after tomorrow. We have plenty of time to adapt to it. Okay, so session 2 today, we're going to talk about the extreme difficulty, the geology portion, of what living species have had to go through just to sustain life. We like to complain about how difficult things are today and how the storms are getting worse and this and that and everything else. Well, you're going to see by looking at the past, we have seen huge obstacles to just things staying alive. And we're going to take a look at all the dangers that existed and that have moderated over a period of time. We're going to take a look at the ways that we are mitigating climate change. We're very unhappy with the fact that the global temperatures are rising, and we are basically focused on one thing, and that is adapting to the current climate change, and we are trying to adapt the atmosphere, pulling greenhouse gases out, limiting greenhouse gases. The question is, will this work? And it certainly has a certain probability of total failure. And we're going to take a look at this. And another thing we're going to do then is we're going to look at a number of miscellaneous things towards the end of the session. We're going to take a look at global temperatures over the past You and I are familiar with the fact that we look at temperature changes over the last 10, 20, and 30 years. We're going to go back 500 million years ago, and you're going to see something entirely different. So with that, and then we're also going to talk about net zero, which is the buzzword on climate mitigation. So with that, let's dig in, and we're going to take a look at some of the major obstacles that have made it very hard for living species to continue their sustainability of life. First of all, the Earth has witnessed 12 ice ages. Now, this is not just a little bit of frost and snow and a few little blizzards here and there. This is a tremendous amount of ice with ice sheets, maybe a half a mile deep, maybe a mile, 2 miles, 3 miles deep and more. This is a simulation of what the next ice age might look like. Geologists are pretty much convinced that we will see another ice age. They have recurred in cycles. 12 of them have existed in the past. And keep in mind now, you can see the, let me see how I can work this. This doesn't seem to be working. All right, there we go. Okay. Here's the United States right here, and Mexico down here, the Baja Peninsula. And you can't really see a lot of this because of the fact it's all covered in snow and ice. However, if we take oh, come on. Okay, there we go. Here you can see the West Coast. And if you can see, it's kind of curved. And the furthest part out in the West Coast, that's about halfway between the Canadian border and the Mexican border. And if we draw a line through that point, going across parallel to the Canadian border, it basically divides the United States up into two sections, equal, north section and a south section. And you can see the, come on. There we go, okay. You can see all of this ice sheet that is below the halfway point. That exceeds the void above this line, letting you know that this is saying that this next ice age is going to see over 50% of this country under ice sheets. Again, this is not just frost and snow. These are thick ice sheets. And I'll point this out. I included this because it shows an interesting point. Some geologists think we are spending too much time on global warming and we are doing absolutely nothing to assure the survival of the human species once this thing comes about, if it does. And it just shows you that different areas of science have different perspectives on what we need to do in order to survive, make sure that the human species survive well into the future. So these are the ice ages. There were 12 ice ages. This is just a chart of the names and when they occurred and all that kind of stuff. Take a look at that. Snowball Earth. This is an ice age on steroids. This happened about 700 million years ago. And there's some interesting theories on what might have caused this, but the entire Earth froze over. The average depth of that ice is estimated by scientists to have been 3/4 of a mile deep. And this presents a very interesting problem for scientists because scientists would look at that and would say, that is a dead planet. There is no way the sun can melt that ice. And you can see why. Take a look at that. Look at the color of snow and ice. It's bright white. And when sun's energy strikes that surface, it's reflected right back into outer space. And there's no chance for absorption. Now, water, you can see a little bit of water up there in the upper right-hand section of it. That is a darker color. Water absorbs energy from the sun. The ice and snow reflect it. Now, we're in an interesting situation today because we have a situation where the ice sheets are melting. And oh my gosh, each year they melt more than they melted the previous year. Well, if you stop and think about it, that scientifically makes sense because as the ice sheets melt, you get more water and less ice. And the water absorbs the energy, which is going to increase the temperature, and there's less ice to reflect the energy back. So each year, you're going to have more water to increase the absorption for the following year. So what is happening is totally expectable. The good news is you're going to see just because the ice sheets are melting now does not necessarily mean that it won't reverse. You'll see that as we proceed onward here. We're now going to look at 5 mass extinctions that occur earlier in the history of the Earth. And these are periods of time that literally wiped out almost all living species on Earth. These mass extinctions occurred between 33 million years ago and 540 million years ago. And here is a table that just simply shows to you the approximate time of each one of these mass extinctions, and also what is estimated what percentage of all species on Earth were killed off. So you can see 443 million years ago, something happened that killed off 85% of everything that was alive. Only 15% survived. 374 million years, 75%, everything killed off. 25% survived. 250 million years ago, 95% of everything alive wiped off the face of the Earth. 200 million years ago, 80%, and 66 million years ago, 78%. Now, let's bring this up and compare it to contemporary situations. Let's take a look at the Spanish flu, which occurred somewhere in the order of 1918. Scientists estimate that during the Spanish flu, which is the worst pandemic that we have ever known that humans have suffered through, wiped out 4% of the human population. 4%. Now compare that to those percentages. Not only that, but that percentage, 4%, is based on the total count of humans. Now, if we were to take the denominator of that ratio and increase it by all the additional living species at that time, in other words, take the total sum of the humans on the planet, then add the total sum of everything else, that ratio would drop to approaching 0. You would have to go several digits to the right of the decimal point before you would find a non-zero digit. So you can see we have seen nothing like what you hear in the past. The mass. Okay, there we go. I got to keep this pointed the right way here. Major volcanic eruptions. And go to the next slide. A partial list of the major volcanic eruptions that have occurred. This is only 1/6 of the total list. I would need 5 additional screen captures to include all of these major volcanic eruptions. Now, my recollection, as best as I can remember, is throughout my whole life, we have only seen an example of one volcano erupting at a time. We have one volcano, then there's a big pause, and then there's another volcano, et cetera, et cetera. What you're seeing here is mostly multiple volcanoes going on simultaneously, and one single volcano raises havoc with the atmosphere, but a whole series of them just really is a major situation that is pretty hard to deal with. Now, volcanoes, look at that on the right there. When they're during the time they are erupting, that flume that's heading up into the atmosphere, a lot of that gas is sulfur dioxide. Sulfur dioxide is not a greenhouse gas. Now, greenhouse gases are the culprit of global warming. What happens is they get into the atmosphere and they absorb sun's energy as it tries to pass through the atmosphere to get down to the surface of the earth. The main greenhouse gases that are in abundance in the atmosphere are methane, carbon dioxide, and water vapor. These are the culprits. Sulfur dioxide is not a greenhouse gas. It gets into the atmosphere and it reflects the energies of the sun back out into outer space. So what that means is the volcanoes go through a period of producing global cooling. Now, one volcano, even though it raises havoc with the atmosphere, it probably doesn't cool the planet anywhere near enough to even measure it. But when you have a whole series of volcanoes going off at the same time, we have a significant period of global warming following the eruption of the volcano. And then, of course, after or during the eruption, there is some level of global warming just because of the heat that is involved. Now, so we're pretty much done with most of the geology. The Earth has always been a very dangerous place for any living species to live, to maintain its existence on Earth alive. Now, some geologists, it's kind of interesting, there are geologists who believe the last 10,000 years have been very calm compared to the previous 4.6 billion years all in total. And out of the last 10,000 years, the last 400 years have been very calm compared to the previous 10,000 years. So we can whine and moan and groan and everything else about how difficult things are today, and yet you just be glad that we weren't around trying to survive in the earlier times of the planet. Now, that's not in any way to belittle, and this is kind of a bad time to be talking about it in this direction after the horrific and very, very sad fires in California. And there is no two ways about it. That is a real tragedy, and it is really a very, very sad thing. There's nothing easy about that. But you can see from what you've seen on these slides here, it was really very, very bad during the earlier years of the planet. So now we're going to take a look at some miscellaneous things. And the first one is still dealing with the geology of the Earth. This is a temperature graph going back 500 million years and showing you exactly what happens here. And before we get into the analysis of the graph, I want to talk about this type of a graph as in general, and I want to give you the source of this information because this is going to be earth-shattering, I think, to probably many of you, this graph. First of all, anybody who tries to tell you what happened 500 million years ago, it is nothing but a guess. That's all it is a guess, period. And so it's always going to be subjected to criticism and revision and all that kind of stuff. Now, I would call this an educated guess. This was put together by very talented people, and they certainly have their reasonings for plotting it out this way, but it is only a guess. And let's take a look at who did this. This was adopted from the Smithsonian Institution. Now, I've always known the Smithsonian as being a series of museums, but it turns out they also are very much into research. They have the Smithsonian Institution that has a number of research centers here in the United States, and one of the areas that they research is climate. This graph is distributed by climate.gov. Climate.gov is a division, or this is placed, it's a website placed on by NOAA, that's National Oceanic and Atmospheric Administration. And so that's a division of government. So this is the one who's promoting this thing. Now, the Smithsonian Institution is a private institution, although they are funded by the federal government by appropriations, and NOAA is, of course, a division of the federal government. Now that we've given you the background of where this came from, let's take a look at the graph. You can see the graph over on the left, 500 years ago, and then we move forward to today. The temperatures wobble up and down and up and down and up and down. And when you look at the 30 years of temperature change, it's just straight up. But they wobble up and down. Also take a look at the, as they wobble up and down, take a look at the peaks, the high points. The high points tend to level off. They tend to cool off, whereas the troughs, the bottom part of the graph, tends to just stay pretty much equal, the very bottom parts of the graph. So the average temperature is going down. Now, this is quite contrary to the expectation that the sun is increasing in energy. The reason why this happens is believed to be because of the change in atmosphere over time. The atmosphere in the early days was almost all methane, and methane is a very, very powerful absorber of sun energy. And as the methane got displaced with other gases, like oxygen and nitrogen, other gases, what happens is that the atmosphere cooled down. And so you can see that that's probably the explanation of this thing. Now, this is going to be the shocker for a lot of you. Notice the graph is partly in red and partly in blue. The entire sections in red are to have occurred during a time when the world was without polar ice caps. No ice on the poles, nothing. The bottom part, the blue part, of course, is where we are today, and that is with the world with polar ice caps. Here we are today, right here on the very, oh, come on. Here we are today, right at this point here. You can see that that's an upward trajectory change in temperature, but we are well below average today, way, way, way below. And in fact, we really are sort of coming out of a mini ice age. Even though we complain about the heat, it's nothing compared to what it's been in the past. Now, we are all concerned. Oh my gosh, what's going to happen? The ice sheets are melting. What in the world is going to happen? Well, if you look at this graph, this is kind of interesting because where we are today has occurred, well, right here. This has occurred many times before. It's occurred here. It's occurred here. It's occurred here, et cetera, et cetera, et cetera. So what we're seeing today is nothing that hasn't been repeated. Of course, there's no guarantee that history is going to repeat itself, but it has in the past. So let's just go through two quick scenarios, and let's just assume that at this time, this situation right here is going to see a replay of this, because right here, we're rising in temperature. So what's going to happen is it's going to continue to rise, and the ice sheets will continue to melt until all of a sudden you get to that point right there, and lo and behold, the ice sheets are already melting. They're all gone. They've gone. They've melted away. We can't complain about ice sheets melting anymore because there's no ice sheets to melt. They've already gone. So what's going to happen? Well, the temperature keeps getting warmer and warmer and warmer and warmer, but eventually it levels off, and then the temperature starts dropping, and lo and behold, all of a sudden the ice sheet masses start increasing again, and the ice sheets come. So they come and go. So not to say that this is not a very precarious situation, because if all the ice sheets melt, that's a tremendous amount of water that's going to be added to the ocean. And the ocean levels are going to rise, and that's going to mean we're going to lose a lot of land. A lot of land that's above water today is going to be underwater. Coastal regions of all the continents and some islands have such low elevation, they will be completely wiped out and be underwater. So this is not to minimize the horrific events of this, but it is just to point out that according to this graph, this is just part of the natural recycling process that goes on with the Earth. Now, this is a global average temperature change. This shows you the rate of temperature change. This is over a shorter period of time. This is from year 0 to year 2000. So this has a span of 2000. The last graph had a span of 500 million. So this period would be just a dot on the previous graph. And you can see that for a long period of time in the earlier days here, you can see that the change was going somewhere between 0 degrees Celsius and 1/2 degrees Celsius. And it's been wobbling around until all of a sudden at some point there was a tremendous increase in the rate of change of the temperature. By the way, this is over a period of 10 years. The default interval on measuring temperature change on the globe is 10 years. And basically what this says, like for instance, if you read this graph right here, this point right here, let's just say that occurred at right here. Let's say that that's about 1930. And you go back over here and you read 1 degree Celsius. What that's saying is that whatever the temperature was, it is at this time, it was 1 Celsius degree colder 10 years ago. So it's just a measure of change, that's all. And by the way, if I can bring this back to the last graph, this vertical rise over here, the vertical rise on the right, you can see that on this graph way over on the right side of this thing. I think this thing just might have died on me. Oh, okay, I'm not looking at the right side. That's the same vertical rise right there. And by the way, while we're looking at this, one of the things that alarm climatologists is the slope, the steepness of this, how it's almost vertical. That has only occurred one time in the history of this graph, and that is right over here. You can see that's very vertical as that rises. And the rest of those have a not quite as steep a slope to them. Okay, net zero. Now we're getting near the end of this. We're going to talk about net zero a little bit because this is the buzzword. This is our main and only, right now, means of dealing with climate change and try to reverse the direction, try to cool the planet down. And so it's very important we understand net zero and what it is and take a look at what is the probability of its success. Net zero basically says that we as human beings have to take out any greenhouse gases from the atmosphere that we put in. We want a zero balance on this. So in other words, we're not contributing in any way to what is causing this global warming. And all the countries are behind net zero. This is the buzzword. One country's they're gonna reach net zero in 10 years. Another one's gonna reach it in 5 years. This is the total buzzword. Well, that's fine and dandy, except there's one problem with this. Well, there's a whole bunch of problems with this, really, if you stop and think about it. But there's one problem that is really significant, and that is nature produces a tremendous amount of global warming gases on its own. And net zero has nothing to do with it's just ignoring what nature is putting in. Now, how can we arrive at net zero? Let's say we still want to try to arrive at that. Well, there's two ways we can reach net zero. We can stop putting greenhouse gases into the atmosphere. And anytime we are using fossil fuels, we are putting a tremendous amount of methane and carbon dioxide into that atmosphere. Now, one thing we could do, if we shifted to nuclear power, which I have always been in favor of personally myself, if we did that, that is a very clean form of energy. That does not produce any greenhouse gases. Another thing that we can do is, in theory, we can decarbonize the atmosphere. We can pull some of the greenhouse gases out. That is a tremendous amount of research on it right now today that is very economically unfeasible. It's very, very costly. However, we can always hope for a scientific breakthrough. We have a great deal of research going on in that direction, and scientific breakthroughs are what propel forward modern civilizations. So we can always hope for that. But in the meantime, what we want to do is we want to take a look at the way, some of the ways that nature puts greenhouse gases into the, there we go, okay. Take a look at all that bubbles, or the bubbles coming up of that lake. This is up in northern Alaska. It's Easy Lake, spelled E-S-I-E-H, named after the, okay, thank you. Named after the, by the native Alaskans. This we took note of this 2014. It's just a tremendous amount of something going up there. If you were in the boat where this picture was taken, you could hear loud the gurgling. So this was a puzzle. This is a small lake by Alaska standards, and it's very shallow. And this was, they really couldn't figure out what was going on. They had to bring imaging equipment from the United States military to check this thing out. And they found a very deep hole that they referred to as a chimney going well down below the frost line. And that's methane coming up out of that. Scientists believe this one lake alone is putting 4,400 pounds of methane into the atmosphere every single 24 hours. One lake alone. And Alaska has 300 lakes, the northern part of Alaska, and they're all doing the same thing. Not to the extent of this. By the way, if you want to do some research on this, you can just spell this Easy Lake, E-A-S-Y. The browsers know exactly what you're looking for, and they'll take you right to it, because this lake is known probably by every single climatologist in this country and perhaps all over the world. But anyway, let's move on here. Methane is highly flammable. That is the main content of natural gas. Take a look at these. These are sinkholes in Alaska. They are absolutely humongous. These were discovered by a pilot flying a private aircraft. He notified the officials, and scientists got on this right away to take a look at it. These are huge. They say you could put a 19-story building inside of that hole. This gives you a better idea of how big these are with the humans standing right at the perimeter of this thing. This perplexed science for a while. Come to the conclusion that this is an underground explosion, and what happens is methane rises up from deep down underground, and it gets trapped. It cannot break through the crust of the earth, and so it accumulates just below the surface. And then all of a sudden there's some ground shift, which produces a spark, and boom, you get this huge explosion. And then all around the perimeter of this is all that ground that blew up into the sky, up into the atmosphere, and just landed around the perimeter of this thing. And anyway, so these are a lot. Sinkholes. There are a number of these in northern Alaska, a good number more in Siberia. Okay, as if that's not enough, The permafrost in Alaska is melting. Permafrost, that's supposed to be permanent. Well, it was up until about 1960, and around 1960, it started to melt. And that has raised havoc with Alaskans because they have used permafrost as bedrock to anchor their buildings, their houses, et cetera, into it. Now, all of a sudden, their base support is melting. And it's producing a tremendous amount of methane and carbon dioxide just going right into the atmosphere. The reason being is because the permafrost is not just pure frozen water. It contains a lot of parts of dead vegetation. You got parts of trees, parts of bushes, grass, plants, et cetera, et cetera. During the time that was frozen, the decomposition was halted. Now that it's melting, the decomposition is continuing, and it's putting a tremendous amount of greenhouse gases in. The melting started in 1960s, and the last couple of decades it has grown very, very rapidly. So methane and oil naturally rise to the surface, and also to the surface of the earth and to the bottom of the ocean floor over time. These occur naturally underground, and they rise up. The first oil wells were drilled where oil was already seeping through and was visible. And the imaging and sensing techniques came later on. So whether we drill for oil and gas or not, we're still going to have it coming up and getting into the atmosphere on its own. Okay, we're getting very, very, very close to the end of this thing. So the point of the matter is we can meet net zero, but net zero has nothing to do with the ever-increasing deposits into the atmosphere from nature. Now, I've tried to keep my opinions out of this, but I want to expose you to the opinion of a very well-known and heavily followed author. Her name is Gina Vince. She's European, and she has written an article. This was in, I think, August of 2022, Where We'll End Up Living as the Planet Burns. She is a well-followed science journalist. By the way, those of you that are familiar with TED Talks, how many of you are familiar with TED Talks? She's on that circuit. She speaks. And if you're not familiar with that, these are high-profile people like Bill Gates, Elon Musk, Jeff Bezos, et cetera, and she is on that speaking circuit. And what she is saying is, here's a summary, there is no way to adapt. People will have to move. People will have to move. Billions of people are displaced and seeking new homes. This is a long article. It's available if you go into the Time magazine website. You can easily pull it out by just putting her name in, Gia Vince. I have a copy of it on my computer. I'll be glad to email it if anybody wants this. It's a long article, and it talks about where we can move. It looks at long-term temperature expectations. She is predicting that we are going to see the largest migration among humans in human history. And this is going to occur within the next 76 years. We can talk about... This isn't cooperating, my push button isn't cooperating, or maybe it's just me not cooperating. But anyway, she's predicting that we're going to see the largest migration, and the migration pattern is very easy to understand. People are basically going to be moving away from the equator towards the poles and away from lowland and into highland. And she says that this adaptive thing is no way to adapt. She says that all of this stuff dealing with net zero and everything else is going to fail, and the planet is going to continue to warm. And now this is her opinion. And again, we can always hope for scientific breakthroughs. And so we just kind of have to see what happens. Well, the question is, okay, moving from the equator to the north and from lowland, that will work for a while. But by the time the sun turns into a red giant, it isn't going to do any good, because nowhere on the earth is it going to be, can you stay alive? So what do we got to do? Eventually, if humans are going to survive well into the future now, this is not tomorrow, they're going to have to move to another planet. And yes, guess what? Scientists have been on this for years. They already have plans for this. And one of the key plans is they have a number of places picked out. And believe it or not, one of these is a moon traveling around, orbiting around Saturn, called Titan. Now, the reason why they picked out Titan is because, first of all, the Earth, that moon is somewhat similar. You've got to move to a planet that is somewhat similar, where people can actually physically withstand the gravitational change and other things like that. But Titan is kind of an ideal place to consider for future home. They have oceans, and they have rivers and lakes, and they're filled with liquid. Not water, frozen methane. 400 degrees below zero. I'd say a little too cold to take a swim, wouldn't you? Anyway, the theory is that as the planet warms up, because of the increasing in size and increasing the surface temperature, it's going to warm up the whole solar system, and it won't take much of a warmth to get all of that methane evaporated. And what we'll have is a bunch of dried up ocean beds and river beds, much like we have on Mars, Mercury, and Venus today. And that will be very convenient. All we got to do is fill it up with water before we move. And scientists have plans for that too. So anyway, question is, we're right near the end of this thing. What do you think? Should we concentrate on trying to adapt, which is what the entire world is concentrating on right now? It's a one strategy process, and the whole world is on this net zero. Or should we concentrate on moving in two stages, first to the poles, as Gina says, and then second, work, we can just move to another planet. Fortunately, it isn't going to happen tomorrow, and it's not going to happen in our lifetime, so we won't have to worry about it. Nor will your kids or your grandkids. But now, I want to call yourself, if you're really interested in learning something about climate change, I suggest this document, the Intergovernmental Panel on Climate Change. They put out a detailed report, Climate Change 2023 Synthesis Report. I have not looked at this yet, but I know the 2022 version was over 2,000 pages. So I suspect this is going to be a very long, detailed report. It's all scientists. The Intergovernmental Panel on Climate is a division, was put together by the United Nations. This is the document that all countries are using to form their policies. It is a document that all kinds of politicians use and journalists use. Unfortunately, politicians put their own spin on it, and they're going to reinterpret it the way they want to interpret it. Journalists want to reinterpret it so that it draws attention and increases readership or viewership. So you got to be very, very careful with this. This document might be the most misdocumented, the misquoted document that has ever existed. So this is a very good place to go to actually get the information. By the way, the website is filled with smaller reports, just a lot of information on this thing. So we're done. Almost all of the slides came from either the NASA website or other websites hosted by various research institutions. I did use some open source pictures, which anybody is free to use anywhere, to try to keep the presentation on solid legal grounds. Thanks for attending. How did I do time-wise?
Great. You did great.
Okay, great.
Questions?
Hi, fascinating. I have a question on this moving. I mean, countries won't, what, are we going to try to be one global entity? People aren't going to do that readily.
Well, right, because of borders, not being able to move across. In fact, she actually makes Gina Vince comments about that. And this will not be pleasant ears to conservatives, because she says countries are going to have to open up their borders. They're going to have to just realize that people are going to have to do this, and so they're going to have to allow for free flow of people. So this is not pleasant. This is not pleasant to the conservative ears. But you do raise a point. Yes, they're there, and she indicates the problems on this. And even if the borders open up, it doesn't mean that the local people up in these rural areas are going to be real accepting of outsiders either. So she calls all this. It's a very interesting article. It really is. Good question.
So my question has to do with this issue of adaptation.
Yes.
Your presentation showed that many species in the world have adapted over time to severe weather events and come back. So my question is there a strategy that we can use to get humans to adapt and eventually learn to live with higher temperatures?
Well, that's a very good question. And yes, there has been significant adaptation. And I think a lot of that kind of just occurs naturally through evolution. Right now, the governments are very narrowly focused on one thing. And that's the buzzword, net zero, net zero, net zero. And they are not looking at different alternatives. My guess is, if we succeed, fine, that's great. We hope we're successful. And scientific breakthroughs might come through. And if we could move rapidly, it's kind of interesting. Nuclear power, that was very well accepted by the general citizenship, and then it waned, and it turned very, very, very negative. Now that's increasing. Now we're going back, and we're realizing that nuclear power probably does play a very important role in our future power of this country. So the attitude seems to be changing, and only time will tell what is going to happen. But that would make a big difference by reaching net zero, by stopping a great deal of what we're putting into the atmosphere. And there's research going on, and trying to take the greenhouse gases out and burying them underground. Right now, I mean, this is just absolutely cost prohibitive and is producing, none of this is anywhere near coming into reality. Still a lot of research to go on.
Next question.
Yes, I appreciate your opinion on this. There are a number of scientists who claim that the shifting of the globe on its axis has caused climate change. And for example, cities that are cold are getting colder, cities that are close to the sun are getting hotter, regions of the country that get a lot of rain are getting more, others are getting less. And I appreciate your opinion on that, whether global axis is a factor here.
Well, that's right. In fact, all of the planets have the axis is tilted. They're not perfectly perpendicular to the overall general plane of the solar system. However, I would argue, and I am not an astronomist, but I would argue that the tilting of the axis has to play minimal content, because all it's doing, if you change the tilt, you're just changing what portion of the globe is facing the sun. But you're not changing the distance from the sun at all. So I would argue that it probably plays a very insignificant role. Now, as you tilt the axis, or as it tilts, it exposes potentially different areas of high dense population. So the effect on the humans could vary a little bit, but my guess is overall the effect of that tilt is insignificant. Even if you were to tremendously change the tilt, it just changes what portion of the Earth is getting the sun at that particular time.
Next question.
Thank you. Very wonderful presentation. Reminds me of being back in school. I'm over here. Yoo-hoo. And my question to you is, being a former educator, and science is very enlightening and informative and helps But we seem to be going in a different direction in regards to education, with so many people saying it's not science, right? Denying science, denying the reality, and seeing what's going on in California that is just horrific, and knowing that it's going to get worse, and seeing a fire, tornado, and all of this. The question is, how do you get people, the people in general, to recognize science again and the importance of it?
If you come up with an answer, you let me know, okay?
Next question.
People are very hard to predict, and people they love to veer off into nowhere land. And the further they go out, the more they can tend to even drift further. And that's a very good question. I will say one thing. I think that we do some things to create some confusion here, because there are two issues. There is the issue of climate natural change, which is what is happening, and the issue of what we can do to alter that. Those are two different things. And when you just put this all together, well, what do you think about climate change? I did not, climate change is all fictitious. Well, anybody who can just take a look at temperature statistics and heat statistics, I mean, you can see it's changing, you know. I mean, you have to just tune yourself out. But we tend to just associate the two together as climate. And we need to specify the current conditions on climate change and what we are trying to do to alter the future direction of climate change. And we don't want to jump them together.
Some of the solutions or suggestions that you mentioned are cost prohibitive or very costly. It seems to me going to Titan or Mars or anywhere else is also very costly. One of the things you didn't happen to mention, is there any way that all of those sinkholes and methane, the areas where methane is just coming up naturally, of controlling those? And yes, that would be costly, but is there an option for that? Is that being studied?
Okay, first of all, with reference to your first statement, traveling to Mars or what have you, well, you have to remember that there are tremendous strides being made in space travel. And one of the things that, space we went to the moon, and then there was a huge pause where we really didn't hear much about what NASA was doing. Now, all of a sudden, this is back in vogue. And one of the things that's happening is NASA is now working independently with private companies. You've got Jeff Bezos working. You've got Elon Musk working. And we have a gentleman right here in North Las Vegas. His name is Bigelow, and he's making capsules that people can live in. So you have a lot more, you have many more brains involved in this space. I think you're going to see space travel is going to go through revolutionary changes, and I think that there's probably some very good possibilities, some major scientific breakthroughs that's going to make this possible, probably somewhat in the near future, in my opinion. Now, the second part of the question, can you refresh my brain? This brain doesn't work very good. Oh, yes. Yeah, good point. Sorry about that. Yes, I don't see any possibility of that at all, because that's going on all over the world. It's going on everywhere. Wherever you have vegetation, you have the stuff dying, and it works its way underground, and then over a period of time it forms oil and it forms methane, and then both of those rise up to the surface. So the only way, I suppose you could stop it if you killed all vegetation on the earth, but that would present a real problem if you did that. I don't see any hope for that. You're dealing with this going on huge amounts of surface. I think we're going to have to deal with it. Now, if we're successful at lowering the temperature through other means, then perhaps we can slow the rate of that development. Like, for instance, we can stop the melting of the permafrost and So I don't know. I don't see much hope in that. I see a lot of potential for space travel. I don't think traveling to Mars is going to be, or any other planet here in the solar system. I think that's inevitably going to come in time as we improve the efficiency. One of our big interests in the moon, by the way, is that it's going to be a lot easier to launch space travel from the moon because it has much less gravitational opposition to reaching outer space. So there's all kinds of reasons why we have interest in the moon, and that is one of them, is that would kind of be a major launching pad for future space travel. By the way, just one point I want to make out, that those Alaskan sinkholes are totally different from the sinkholes in the lower 48. The lower 40, like the ones in Florida, Texas, and California, they are formed through the flow of water underground. And that's a whole different process. And these are entire different sinkholes, although they're given the same name, that's all.
Well, we're out of time now, so thank you, everybody, for coming. And thank you, John, for this wonderful presentation.
My pleasure. Thank you for attending. Thanks for the invite.